Hello, my lovely viewers and my dear students. Welcome back to yet another session of my distance learning classes. So this class is in continuation with the last video that I had uploaded for grade 9 and 10, which was on the topic of surface area of prisms. So the next topic that we are going to do just after that is today's session. The lesson name is surface area of cylinders. So let's get started with today's session. And I would like to thank you all for liking, sharing and subscribing to my channel. That is what is a good motivation for me, so keep doing that. And it's a humble request, you can share the video to your friends, to your relatives, whosoever find it useful for grade 9 and 10. Now get to know our learning objectives for today. So the first learning objective that we are going to be focusing on in today's session will be to finding the lateral or curved surface area of cylinders. Then we'll move to finding the total surface area or the surface areas of cylinder, and finally we will solve some problems on the concept of surface area of cylinders. And let me remind you, this is a very important topic. Many questions come in the exam from the concept of surface area of cylinders, so this is going to be a very beneficial video for all my grade 9 and grade 10 students. So I would request you to watch the video till the end, and then towards the end I will have some questions posted for you. Try and check your understanding by answering those questions. Okay, so let's begin. And on this screen now you are able to see some pictures. I want you to observe these common shapes and tell me what is the similarity in them. You can pause the video, think a little bit, take a few seconds, and then give me the answer. I'm sure you must have observed that all of them have the common similarity that they have the same shape, which is the shape of a cylinder. So these are some common examples of cylinders from your daily life. Seen some examples how cylinders are there in the life around us, how we can spot shapes of cylinder in common objects like a battery or the shape of a dustbin or the shape of a thick candle, like that. So I want you to think a little bit more on this and type in the comment section what more examples of cylindrical shapes and solids can you find from everyday life. I will be eager to know that. Feel free to comment and think about how you can relate this concept of cylinders to your everyday life. So the common observation that you would have seen in all those shapes of cylinder brings us to the question, what is a cylinder? How can we define it? So let me give you the definition along with the explanation. Cylinder is defined as a special kind of prism. So the last video that we had done for the surface area of prism told you that a prism is a shape which is having the opposite bases as congruent shapes. So here if you observe the image of the cylinder which is provided, the base of the cylinders are two circles and definitely they have the same radius, they are congruent to each other. So we can define a cylinder as a special type of prism which is having circular bases. Now this cylinder, as you can see in the image, has two parts. One is this blue part which is curved, and the other two are the two circles which are at the top and the bottom forming the base. So based on this description, we are now going to be defining the two important concepts of surface area of cylinders. So let's get ahead. Okay, so the first concept, that is our first learning objective, is the lateral area of a cylinder. It is also called as curved surface area of a cylinder, and both of them have the same formula. You are going to compute these areas using the same notation. So in the last slide, we saw that cylinder is a special kind of prism. So definitely the lateral surface area of a cylinder can be computed by the same formula that we learned for prism. That is P times H, where P is the perimeter of the base and h is your height of the cylinder. Okay, so what do you think is the perimeter of the base here? So if you look, the base is a circle, and the perimeter of that circle is nothing but the circumference of the given circle. So if you observe, let me just highlight the base here. So this base, the circle, now I'm drawing by freehand, so it will not be a perfect circle, but I just want to highlight to you that the two bases, which are the circles, are congruent here. They have the radius r, so we can define their perimeter in terms of the circumference. So the circumference of circle, the formula you all know, is 2 pi r, where r is the radius. If we now replace the perimeter with the formula for circumference, so that brings us to the final formula for lateral surface area, 2 pi r times h. Remember, r is the radius of the base, the radius of the circle, and h is the height. So this is one formula which is very important. If you remember it correctly and apply it to the questions correctly with correct calculations, you can get full marks for a question on curved surface area of a cylinder. In this slide now, we move a step further, and now we are talking about the total surface area of the cylinder. Now, when it comes to total surface area of a cylinder, it means we have to just add up all the parts of this cylinder. So we'll add up the area of the two circles to the lateral surface area. So that is again this formula. So 2 times capital B, that is area of the base, plus the lateral surface area, that is P times H. So this formula is directly coming from the prism. And after substitution of my values here, we can get the total formula for the TSA of a right cylinder as 2 pi r square plus 2 pi r h. Now let's come to the notations. So h here is the height of the cylinder, r is the radius of the base. Now if I may ask you from this one to this one, how did we go? Then I'm sure my viewers, my students are able to identify that P, which was the perimeter of the base, or the circumference of the circle, is 2 pi r. That's what we have substituted. And capital B is the area of the base, which is nothing but the area of the circle. So the formula is pi r square. So when we do this substitution in the first formula, then we are getting the same formula for total surface area. So this total surface area, let me remind you, is the sum of the lateral surface area and the area of the two bases, which are circles. Again, I want you to be remembering this formula. It's an important one. And once you apply it correctly, do correct calculation, you're going to be getting the correct answer for total surface area of a cylinder. Students, so now that you've seen the two formulas that will help you for calculation of the lateral surface area and the total surface area, it's time for us now to try an example. So I'll read the question for you. A cylindrical bass drum has a radius of 5 inches. So while I'm reading, I'm also highlighting the important numbers or the important information which is given in this question that will help us to solve. So the radius is given to you, that is 5 inches, and the depth of the cylindrical drum is 12 inches. So two things are given to you, and let's see what you need to find. It's given that you need to find here the surface area. So we are going to go first for the lateral surface area, and then we'll go for the total surface area. So let me draw the figure for you. This is the cylindrical drum. The radius is 5 inches and the depth, or in other words, we can say the height of the cylinder, is 12 inches. So now we write the formula for the total surface area. So that is equal to the lateral surface area, 2 pi r h, plus the area of the two bases, area of the two circles, 2 pi r square. Now two things are already given to us. We know the radius, that is 5 inches, and please don't forget the unit. Unit is very important. And we're also given the height. Height is 12 inches. So these two now we are going to just substitute here in the formula. So we're using the method of substitution, and then we are just going to be simplifying and calculating the answer. Note the base here is the circle which I've highlighted here. This area I have highlighted with blue color. So that is your area of the base. So 2 pi times r square. So we just have done here substitution, plus 2 pi 5 times 12. Let's simplify. We get this, and then we can write it in terms of pi as 170 pi. Is the question complete? Is this the final answer? We are missing out on one important point here, which I don't want you to miss, and that is the unit. So remember, it's an area, so the unit is going to be inches square. The dimensions, radius and height were given to you in inches here, and that is why the area is in inches square. Had the dimensions been given in a different unit, for example centimeters, then your total surface area would have the unit centimeters squared. So accordingly, we are going to decide the unit for finding and writing the total surface area. So that completes the question now. We have written the unit as well, so that is the correct way of expressing, of writing your answer. Next in this lesson, I'm going to be covering an important question from the textbook, which is a guided practice question. So first I'm going to be reading it, and then I will highlight for you what is the important information. Find the diameter of the base of a cylinder if the surface area is 464 pi square centimeters and the height is 21 centimeters. Now this question is a little different in the sense that the surface area is already given to you. Yeah. And if you observe, it is given to you in terms of pi. Also, the height of the cylinder is mentioned. And what you need to find is the diameter of the base. So let's first write very clearly what's given, and then we'll deduce what are the steps we need to use to solve the question. The first thing which is given is the height of the cylinder, that's 21 centimeter. And the second thing which is given to you is the total surface area, and that is in terms of pi. So we are not going to be substituting value of pi here, we'll keep it as it is. Because in the next step, when you put the formula for TSA, you will see that pi is going to cancel from both sides. Let's substitute the formula 2 pi r plus h. Now please don't get confused. In this formula, I have written the same formula 2 pi r square plus 2 pi r h, but it's just that I've taken the common factor here. So 2 pi r I have taken common, bracket times r plus h is equal to 464 pi. Okay, so let's cancel now the common factors and try and simplify this expression. So r times r plus h comes out to be 232. Now already we are given the value of h, so let's substitute it at this step and then distribute the left hand side to get the expression r square plus 2r minus 232 equal to 0. Now, if you may think a little bit about it, we have got a quadratic equation in r. So you will have to simplify this, reach to the roots to get to your value of r. And a quadratic equation, if you remember, is having degree 2. So it is going to be having two roots. So we are going to be getting two values of r from here. Let me write down. So when you are trying to solve a quadratic equation, or when you are trying to factor a quadratic equation to reach to its root, here you are going to be selecting two numbers which when multiplied gives you negative 232, this number, and which when added gives you 21. So what do you think? What can be those two numbers? I'll give you a few seconds to ponder about the roots, and then we'll write the correct part. Think about it. If you wish to pause the video so that you could get a few minutes or few seconds to solve, do that. Okay, so I'm sure you have got the two roots as plus 29 and negative 8. So when you multiply them, you can check your values, whether you've got the correct um, factors or not. So 29 multiplied with negative 8, okay, definitely that's giving me negative 232. And 29 added to negative 8 is giving you 21. So, okay, that means these are my correct choices for the quadratic equation. So, I can factor them as r minus 8 times r plus 29. So, these are going to be my two roots or two values of r. One is r equal to plus 8 and another is r equal to minus 9. Now, are we done here? Think about it. And also think about, can R be negative? Can the radius of a cylinder be negative? I'm sure you will agree with me when I say that a negative value for R is not possible. So we are going to be rejecting this solution and we will go with one value, that is R equal to plus 8. And if we read the question once more, then the final answer should be giving us the diameter of the base of the cylinder. So I need to double up my radius to get my diameter of the base. And that comes out to be 2 times 8, which is 16 centimeter. So that's your final answer, which completes this question. So it was quite an important question, and whichever question I find important for your exams, I'm going to be putting a star mark here. So let me remind you, this is quite important from the point of view of your exams. Okay, now, so let's solve together one more question on cylinders. Here, a cylindrical can is given to you. The can of soup at the right has a surface area of 286.3 square centimeters, and you need to find the height of this can. Also, you need to round off the height that you are going to be getting to the nearest tens. That means for one decimal place, you are going to be rounding off your value of h. Now, from the image, I hope you can clearly see that the radius is already given to you, and it is 3.4 centimeters. So let me just highlight the decimal in case you missed that out. So the radius is given to you as 3.4 centimeter. You need to find the height here, and the total surface area of the soup can is already mentioned in the question. So let's get started by substituting the formula and equating it to 286.3 centimeters square. So if you see, this question is very similar to the previous question. The only difference is that in the last one, you had to just find the value of r, and here in this question you have to find the value of h. In the previous question, height was already given to you, and here in this question the radius is given to you. So both are quite similar in the sense that one variable is given, one you need to find. Therefore, the method that we are going to be using will also be very, very similar. So let's substitute the value of r here. We are also going to be substituting the value of pi. So I have substituted pi as 3.14. Now, why I have substituted pi here, unlike the previous question? Because here my total surface area is given to me as a full decimal number. It does not involve pi. So they have already substituted and done the calculation with respect to pi. So we are going to be substituting pi also as 3.14. We are going to be substituting r also as 3.4, which is given in the question, and then we will simplify this expression for h. So let's do that. So you can use your calculator for simplifying this for this multiplication, and this whole part will then come out to be 21.352. Okay, and the bracket is as it is, 3.4 plus h. These are both multiplied and they are equal to 286.3 centimeters square. Okay, now what do we need from this expression? We need the value of h. In order to get that value of h, we have to again rearrange this equation, and that will give us 3.4 plus h equal to 286.3 divided by 21.352. So use your calculator back again. Be careful of your calculations. If you do calculation mistake at any stage of this question, then your answer may not come correct. So you have to be very, very careful with your calculation, with your decimals at this stage. So finally, you can see in the next step, I have got 3.4 plus h equal to 13.40. So I'm going to take my h here only and move my 3.4 on the other side. So the sign changes. H is equal to 13.40 minus 3.40. So what do you get when you subtract these two? I'm sure you agree with me. You are getting 10 centimeters, and the question said that you need to round off your answer to the nearest tenth. So the final answer we will write as 10.0 centimeters, so that it is to the nearest tenth and to one decimal place. So that completes the solution. I think it was a quite a simple question. The only thing you need to be careful of is the decimal and the calculation in this question. That will give you the correct answer. Okay, so that brings us to the summary of today's lesson. So I will give you the key concept now. There were two important concepts we did in today's session. One was the lateral surface area or the curved surface area of the right cylinder, and the second is the total surface area. So let's summarize the formula. Capital L is denoting the lateral surface area, which is 2 pi r h, and capital S is denoting the total surface area, which is 2 pi r h plus 2 pi r square. So this is what I would want you to remember. This is just like a formula sheet that is going to help you for all your questions. So please remember so that you can use them for solving questions very easily and get to the correct answer. Okay, so let's check your understanding. So I have on the screen now two questions for all of you. I want you to try these questions yourself as practice to check your understanding, and then type your answers in the comment section. I will be more than happy to check it for you and provide you with the correct answers and feedback. So that brings us to the end of today's session. Thank you so much, my lovely viewers and my dear students, for joining. Don't forget to like, share, and subscribe to my channel so that I will be more and more motivated and I will be making more and more videos and uploading it for you. See you in the next class. Bye, students.